Hello everyone, I'm Gavin Lu from VMware. Today I'll talk a little bit about smart building and how Kubernetes is used in this case. Let me share my screen. Okay. Smart building is pretty often mentioned in the cases when people talk about a smart city, smart campus, and building automation. And it's pretty near to people because people mostly live in building, right? Either that's an office building or a home building. So there are many cases actually in smart building about the air conditioning, HVAC, and the lighting, smart lighting, and navigation, some other signage in, for example, in a supermarket or shopping mall, things like that a lot. And then people really pay attention to that pretty intensely because people may have a pretty direct interactive experience on that. And for smart building, actually things will be a little bit more complex if that's in office. Here is an example about an office building. There might be many floors, and for every floor, there are elevators, lifters, and on every floor, a lot of seats. And employees and visitors may come here, sit here and there. And one of the major cases people often talk is about all the other lighting and the relative facilities staff to ensure the people staying in the building feel comfortable. At the same time, they want to save the cost from the power saving perspective. So that's a pretty often discussed case, and people may have different solutions to address that. At VMware, we also face the similar situation. Here is a picture about a VMware building at the Palo Alto campus. You may find we also left some intelligent lights there to auto-detect the environmental situation. What's time for that? The lights will be automatically turned on or turned off. And some other facilities will be controlled also intentionally. For example, in some cases, we also leverage the patrolling robot, indoor patrolling robot, to detect physical security issues potentially. And that's a pretty often referred case in the COVID-19 pandemic period. And a very special case, maybe a little bit near the VMware's business, is the data center. Or sometimes that's a colo arrangement in office buildings if that site is not very big. On the left of the page, you may find a typical data center. What was the structure? A lot of rows, racks with rackable servers there, and air conditioning, the power supply systems, UPS, and some other equipment for cooling, and network operator center for some on-site admins to operate. And because all these servers within the data center, all the colo lab rooms, server rooms, they are pretty major user for the power, for the electricity power. And to cool that, the cooling system might be quite complex. And typically they use air to cool, fresh air to cool the system. On the right side, you may find a very vivid chart of the CFD. We call it a computational fluid dynamics, to show the real-time airflow, the temperature, the pressure, all these things, how that happened in the data center. And to get a pretty effective cooling system for every server room colo situation, it takes a lot of time and the resources to get an accurate model. And afterwards, people have to adjust that system to handle runtime situation. But data center or servers are actually a very major power user in the enterprises. You may find that is a lot of bills actually. So we actually did some pretty interesting here to resolve the issue with Kubernetes. Here you may find a very typical data center, the server room model. We actually partner with a few companies to build an artificial intelligence or machine learning model in the data center. We collect quite a lot of historical data and real-time data about the temperature and moisture, environmental data with sensors installed in the server room. And we train the data model, the reinforcement learning data model, to get the parameters calculated pretty accurately. And then we get the result about how we could configure the parameters of all these fans, all these machines to ensure that the temperature could be kept in an acceptable degree. At the same time, we can minimize the cooling power consumption, the workload, the cool air supply, so that we can cut a lot of electricity consumption for the power system. And we can pass through all this circle, this loop, step by step, day by day, year by year, to make that accurate more and more. We already deployed this system into production environment, and in the best case, it could reduce up to 30% of cooling power for big data center. That's a pretty good result, actually. And the joint solution, we call it deep cooling, is advocated to our users, and there is pretty strong interest and pipeline to leverage this solution. And actually, in the edge case here, that will collect all the data for the power meters, for temperatures from the sensors. All these edge applications are running on Kubernetes, which is controlled and operated from a central Kubernetes control plane in the cloud. So that's a very typical usage about Kubernetes operated in the cloud, but running on the edge. Here, the edge is kind of a logical one because physically, the edge box is located in the server room. Okay, and some other interesting case we did is we tried to deploy an indoor patrolling robot on the bottom to run in the data center server rooms. And there are some cameras and edge devices installed on top of this platform, and the laser reader on top of that to find any physical security issues, to work as a moving sensors, a set of moving sensors to get the temperature and other environmental metrics from data center. That's pretty cool case, actually. Also, you may find in some other data centers. Another thing we tried is to use augmented reality technology, which is pretty useful for the IT admins if that's on-site and they want to track certain servers, certain IT assets, whether there are any physical issues, and they can use a mobile phone or an iPad, a tablet to take a picture, or they just shoot videos on the rack, and we will auto-detect the barcode or QR code or FID attached on the server, and we will draw a dynamic chart with the real-time data coming from the backend server. All these data coming from the inventory systems and the IT systems, so the local admin could know exactly what's the applications and workloads running on certain server at real time, and connect that well with the applications between the applications and the physical server. That's to help troubleshooting the root cause of certain outage or downtime, some other issues, which is pretty cool and useful. Okay, so that's all the information I want to share today. Smart building is pretty important and a pretty fancy topic for guys to think about how to enable our working environment and the living environment. And we did some very interesting and practical solutions to manage the assets and power cooling systems in data centers, which will be running in our buildings. Hope you enjoyed the talk today, and thank you for your attention. See you next time. Bye.